Let's talk about iron. It's so fundamental to our world, so literally everywhere, that it's easy to just not even think about it. But the story of how we learned to harness this metal is the story of how we built our civilization. So we're going to dive into how humanity unlocked the incredible power of iron, one innovation at a time. But that story kicks off with a real puzzle, a mystery you could call the Great Paradox of Iron. So here's the big question that really frames this whole thing. Iron ore is one of the most common materials in the Earth's crust. It's everywhere. So why in the world did we spend thousands of years mastering bronze, which needs way rarer stuff like copper and tin, before we ever got to the Iron Age? It seems totally backward, right? Well, the answer really comes down to two things: chemistry and just raw heat. See, copper, the hero of the Bronze Age, has a pretty low melting point. You could basically cook it out of its ore in a decent fire and get a metal you could work with. Iron? It was a whole different beast. It demanded way, way higher temperatures. And even when you got it hot enough, you didn't get this nice, clean liquid. Nope, you got this weird, spongy, gunk-filled mess called a bloom. And that right there was the huge technological wall humanity had to figure out how to climb. So, how did we climb that wall? Well, it wasn't in one giant leap. It was through this brilliant ladder of innovation, starting with the very first, very simple forges. Early iron makers started with something called a bowl furnace, which was basically just a clay-lined pit in the ground. Super simple. The problem? The hot gas didn't spend enough time with the ore, so you got a tiny, pretty crummy bloom. The solution? Simple. Build up. The shaft furnace made things taller, which improved yield. But then came the real game changer in the 13th century, the Catalan forge. This thing used a clever water-powered gadget to force air into the fire, making it way hotter and so much more efficient. Each step was a direct answer to the problems of the last. And you can see the results of all that tinkering right here in the hard numbers. I mean, this isn't just a small step up. We're talking about an exponential leap. Just look at the weekly production. You go from maybe, 150 kilos a week with an early hearth, all the way up to 3 tons a week with the later Stukofen furnace. And at the same time, look how much less fuel they're using. This just shows you plain as day how every single design tweak paid off in a huge, huge way. Okay, so all this constant improvement, all this innovation, it was all leading to one single pivotal moment, a moment that was about to change iron from a difficult solid into a revolutionary new liquid. And the hero of this part of the story is the Stukofen furnace. I mean, just picture this thing. It stood up to 4.5 meters tall, and it was powered by these massive water-driven bellows. This was the final boss of early furnaces. It was the culmination of everything that came before, and it could finally generate enough sustained, intense heat to do what nobody thought was possible, to completely, totally melt iron. And just like that, for the first time in history, we had liquid iron. Now, to cool it down, smelters would pour the molten metal into a main channel that fed into a bunch of smaller molds in the sand. And someone, looking at this setup, thought, hey, that kind of looks like a sow nursing her piglets. And boom, the name pig iron was born. This wasn't just a quirky name. This was the birth of the foundry, the birth of the entire cast iron industry. And I really can't overstate this. That shift from a solid, clunky bloom to a flowing liquid metal, it changed everything. Think about it. Instead of a clunky start and stop process, you can now run the furnace continuously. You just keep feeding raw materials in the top and tapping out pure liquid iron from the bottom. This was the moment that true mass production arrived for the iron industry. But of course, with this incredible success came a brand new and really urgent problem. The industry's thirst for fuel was getting totally out of control, and it led to a full-blown crisis. See, up until this point, iron making ran on charcoal, but charcoal had 3, let's call them fatal flaws. First, it's friable. It's weak, it's crumbly. You couldn't build furnaces too tall or the weight would just crush the charcoal at the bottom and choke off the air. Second, it was ridiculously expensive. And third, the demand for it was causing catastrophic deforestation all over Europe. The very fuel that had built the industry was now the one thing holding it back. So the obvious answer was coal, right? It was cheap, there was tons of it, but it wasn't a simple switch. Not at all. Early attempts just failed because impurities in the coal, like sulfur, would get into the iron and make it brittle and totally useless. It took a major breakthrough by a guy named Dude Dooley in 1621 to finally prove it could be done, and it took decades more after that to really perfect the process. This was a long, hard road, but it was an absolutely necessary one. And that brings us to the final transformation in our story, the moment when making iron went from being a kind of messy art into a powerful science, forging the future as we know it. By the middle of the 19th century, the whole game had changed again. It wasn't just about building bigger, hotter furnaces anymore. Now, thanks to the science of thermodynamics and chemistry, innovators could actually engineer the process on a molecular level. It meant they could precisely control the chemical reactions inside the furnace to create not just iron, but its much stronger cousin, steel, and do it on an unbelievable industrial scale. And that scientific spirit is exactly what drives the industry today. I mean, modern iron making is a science of incredible precision. It's all about optimizing every single variable you can. They carefully screen the raw materials to get the perfect size. They even take ore dust and clump it together into these uniform pellets, they call it sinter, just to guarantee the perfect airflow. They even pre-mix purifying agents called flux right into the sinter itself. It is all about total control for absolute maximum efficiency. You know, this quote just nails it. It perfectly sums up the entire journey we've been on. We started with a simple bowl dug into the ground. But in this relentless push for more and better, humanity replaced that beautiful simplicity with incredible complexity. And that spirit, that drive to innovate and optimize, even if it means making things harder, that's the real engine of progress, and you can still see it dominating the field today. When you look back, the story of iron is really the story of human ingenuity. It's about solving one problem, which then creates the next problem that needs solving, and on and on. This one metal truly did build the modern world. And that leaves us with one last question to chew on. What material, being cooked up in a lab somewhere right now, is going to be the one that forges the world of tomorrow?